Good morning to all. Myself Paras Mehta from BSc Chemistry Honors final year. Today visual impact topic is fats, oil and detergent. Oils, fats are widely distributed in nature both in animals, plants, kingdoms. In animals they present under the skin and in muscles, but in plants they are mainly found in seeds. Some important examples of fat are butter, lard, tallow, beef, etc. While groundnut oil, condensed oil, oily oil, palm oil, coconut oil, Lean oil, etc., are important examples of vegetable oils. Fats and oils are one of the three major constituents of our food, the other two being carbohydrates and protein. In fact, fats and oils serve as energy reservoirs for the animals. In human beings, only a few hundred grams of glucan carbohydrates can be stored, which can be barely supply the body's energy need for about 12 to 18 hours. In contrast, large amount of fats, 20 gram of an average person weighing 70 kilo, can be stored, which can apply the body energy needs for about 8 weeks. Besides this, oil and fat serves as raw material for a number of industries such as soaps, paints, varnish, and vanaspati ghee, etc. Natural fats. The fats obtained from the animal sources such as butter from the milk of cows, lard from hogs, and tallow from sheep, goats, etc., are called natural fat. This name is simply given to differentiate these fats from those fats which are obtained by hydrogenation of oil, edible and non-edible oil. Oils such as groundnut oil, sunflower oil, oily oil, same oil which are used for cooking purpose are called edible oils, which oils such as cotton seed oil, linseed oil, castor seed oil, which are used in soaps, paints, varnish, and lacquer industries, are called non-edible oils or industrial oils. On the basis of iodine values, oil have also been classified as drying, semi-drying, or non-drying oils as discussion in section 9.7. Industrial oils may be include essential oil or mineral oils. Essential oils such as rose oil, jasmine oil, lavender oil, etc. are volatile oils isolated from plants. Essential oils may be hydrocarbons, alcohols, aldehyde, ketones, esters, but not esters for glycerol, etc. For example, peppermint oil, an essential oil, contains methanol and alcohol as its chief constituent. Essential oils are mainly used in perfumes, cosmetics, product. On the other hand, mineral oils is a mixture of saturated and unsaturated hydrocarbon and non-ester for triglycerides. They cannot be sponified. They are called oils because of their physical appearance. They are non-edible or they are mainly used as fuel. Triglyceride composition of oils and fats. As stated above, fats are old triester of glycerol with higher aliphatic monocarboxylic acid. In other words, they are triacyl glycerols and commonly known as glyceride. Fats and oils may be represented by the general formula triacyl glycerol or triglyceride, where R or dash may be the same or different alkyl group. Fatty acid with only a few expansions, all the monocarboxylic acid isolated from fats and oil straight chain compound containing 3 to 18 carbon atom. Further, with the expansion of only C3 and C5 acids, all other acids found in the fats and oils contain even number of carbon atom. The chief saturated fatty acid present in oils and fats are uric acid C11H23COOH, mylistic acid C13H27COOH, palmitic acid C15H31COOH, stearic acid C17H35COOH. Besides saturated fatty acid, unsaturated fatty acid containing one or more double bond in cis orientation may also be present in oils and fats. The chief unsaturated fatty acid present in oils and fats are oleic acid C17H33COOH, linoleic acid C17H3COOH. Now, chemical properties: fats and oil. Triester of glycerol show all the reaction of simple ester. In case the glyceride contain unsaturated fatty acid residue, they also show the usual addition and oxidation reaction of alkene. Some important reaction of fats and acid are given below. Hydrolysis: fats and oil are readily hydrolyzed by treatment with superheated steam. Mineral acid and alkylides: fats and oil react with water at 500 K pressure or HO3 positive gives glycerol and fatty acid. Hydrolysis by superheated steam or mineral acid give a mixture of fatty acid and glycerol. However, when the hydrolysis is carried out by the alkenes, glycerol and salts of fatty acid are formed. Fatty or oil plus 3NaOH gives glycerol plus sodium salt soap. Since the salts of higher fatty acid thus form are used as soap, the alkaline hydrolysis is commonly called saponification. Next is hydrogenation. Oils which contain a higher proportion of unsaturated glycerides add on hydrogen in pressure of finely divided nickel as catalyst to form solid fat. For example, triolene react in the presence of nickel 453 Kelvin 20 to 40 pressure gives triestyrene. The process is called hydrogenation or hydrogening of oils. It is similar to catalyte hydrogenation of alkenes and involves the reduction of double bonds present in unsaturated glycerides to form saturated glycerides. The process is extensively used for manufacture of vanaspati ghee. Hydrogenation is never carried out to be completion but is stopped as soon as the fat of consistency comparable to ghee is obtained. The completely hydrogenated fat are too hard to be useful as kitchen shortening. The main advantage of hydrogenation is that as compared to oils, fats, hydrogenated oils have better storage qualities and do not become resid easily. Hydrogenalysis conversion to alcohol. Fats and oils are treated with hydrogen at high temperature pressure in the presence of copper chromite as catalyst undergo reductive cleavage to form glycerol and long chain alphabetic alcohols. For example, triestyrene 6 plus 6H2O in the presence of CuCl2O for high temperature and pressure gives glycerol plus an octadicyl alcohol. The splitting of a fat or an oil to glycerol and a high longer chain by hydrogen is called hydrolysis. Hydrogenolysis. Transesterification. Fats and oils can be converted into simple esters of carboxylic acid such as methyl ester, etc. by transesterification. It involves the treatment of a fat or an oil with a large excess of suitable alcohol in the pressure of presence of acidic or basic catalyst. For example, alpha oleo B stereo alpha dash palmitin plus 3CH3OH in the presence of CH3ONA gives glycerol mixture of methyl oleate, methyl citrate, and methyl palmitate. The process of transesterification is quite useful for the large scale preparation of long chain fatty acid and long chain primary alcohols of high purity. For this purpose, the mixture of methyl ester obtained by transesterification is subject to fractional distillation to separate the individual ester. These, upon hydrolysis, yield fatty acid of high purity. Alternatively, the individual methyl ester are produced to get long chain primary alcohols. Addition of halogens like alkenes unsaturated glycerides add halogens across the double bond to the form additional product. The addition of iodine is usually carried out by the treating the fat or oil with iodine in the presence of mercuric chloride as catalyst. Triolene iodine in the presence of HgCl2 gives triolene hexa'iodide. Since the amount of iodine used is proportional to the number of double bonds present, therefore this reaction is used to determine the extension of unsaturated in a given fat or oil rancidity. When fat and oils are exposed to warm
Exposed to warm air and moisture for a long time, they develop a disagreeable smell and taste. This process is called acidity and involves the hydrolysis of ester to produce fatty acid and oxidation at the double bond to form short chain acid and aldehydes. These short chain acid and aldehyde are volatile and have offensive smells, therefore they impart unpleasant odor to oils and fats. Acidity is one of the two types. Hydrolytic rancidity. This type of rancidity is caused by the liberation of lower fatty acid by hydrolysis of triglycerides. For example, when butter is exposed to warm air and moisture, the hydrolysis of glycerides in butter yield butyric acid and other volatile acid with unpleasant odor. Butter glyceride plus 3H2O lipase glycerol gives glycerol plus and butyric acid and caproic acid and caprylic acid. The process of hydrolysis is catalyzed by enzymes which are provided by the microorganisms present in the air. This type of hydraulic reactivity can, however, be checked by keeping the butter converted in a refrigerator. Oxidative reactivity. This type of reactivity is caused by oxidation of unsaturated triglycerides by air to form short chain acids and aldehyde having unpleasant smell. It is believed that first the ester linkage are hydrolyzed to yield unsaturated acid which undergo oxidation at the site of double bond to produce short chain acid and aldehyde. For example, oleic acid in the presence of O2 gives palgoinic acid and azelaic acid. Oxidative reactivity can be prevented by the addition of certain chemicals called antioxidants. Two antioxidants which occur in the natural fats are vitamin C and vitamin E. Next is soaps. Substances like soap and synthetic detergent which concentrate at the surface of the solution or interference form surface film. Reduce surface tension of the solution and help in removing dirt and dust by emulsifying grease are called surface active agent or surfactant. The molecules of surfactant contains two characterized group, one of which is water soluble hydrophilic and other is oil soluble lyophilic or lyophilic. Soaps are sodium or potassium salt of higher fatty acid such as palmitic acid, stearic acid, and oleic acid. These soaps are generally obtained by the hydrolysis of oil and fats with aqueous alkalines. The process is called saponification of oils and fats. For example, alpha palmito, beta oil, and alpha estering react with 3NOH gives glycerol and sodium state soap. The fats and oil commonly used for the soap manufacture are tallow, olive oil, linseed oil, coconut oil, and palm oil. Soaps contain 12 to 18 chain atom have good cleansing action. Soap with 12 carbon atom are comparatively soluble in water, whereas soaps contain 18 to 22 carbon atom are not useful as soap because of their insolubility in water. Sodium soaps are generally hard and hence are called hard soaps. These are used for washing of clothes. Potassium soaps, on the other hand, are more expensive and produce a softer leather and hence are called soft soap. They are used for making shaving cream, shampoo, liquid soaps, etc. Transparent soaps are prepared by dissolving ordinary soaps in alcohol and removing the insoluble part by filtration. Evaporation of alcohol leaves behind transparent mass. Soaps are 100% biodegradable microorganisms present in swag water called completely oxidized soaps with CO2. As a result, it does not create any pollution problems. However, soaps have two disadvantages. Soap cannot be used in hard water since calcium and magnesium are present in hard water, producing cloudy white precipitate of calcium and magnesium soap. Soaps cannot be used in acidic solution since acetic acid present in the solution precipitate the insoluble fatty acid which agree to fabric and thus block the ability of soaps to remove oil and grease from fabric. Synthetic detergents. These days, in place of soaps, the substance which are being largely used as cleansing agent are synthetic detergent. As the name suggests, they are obtained from purely synthetic chemicals as compared to soaps which are derived from chemicals which are obtained from natural sources like oils and fat. In fact, synthetic detergents are sodium or potassium salt of long chain alkyl hydrogen and sulfates or aryl sulfonic acid. Unlike soaps, unlike soaps, synthetic detergent can also be commercially used even in hard. This is due to the reason that calcium and magnesium salt detergent like their potassium salt are soluble in water, hence the synthetic do not form quickly with precipitate with hot water. Further, they can also be used in the acidic solution. However, synthetic detergent have one disadvantage. Unlike soap, they are not completely biodegradable and hence cause water pollution. Synthetic detergent had following three types. Ionic detergent, they are so called because a large part of their molecules are anion. These are two types alkyl sulfates. They are obtained from long chain alcohols by treating with concentrated H2SO4 by neutralizing with NaOH. Some important example of these type of detergent are sodium lyric sulfate C11H23CH2O CO3 negative and Na positive plus and sodium citral sulfate C70H35CH2O CO3 negative and Na positive. Sodium lauryl sulfate is also called sodium dodecyl sulfate is SDS and is used in the shampoos and cosmetics. These sodium alkyl sulfate are 100% biodegradable. These are also effectively in slightly acidic solutions since they form an alkoic hydrogen sulfate which is a soluble material whereas soap react with acidic solution to form insoluble fatty acid. Alkyl benzene sulfonates. These are obtained by the conversion of benzene into long chain alkyl benzene followed by the sulfonation and neutralization with the NaOH. The most widely used domestic detergent it is sodium and deoxyl benzene sulfonate. Alkaline benzosulfate in which the phenyl group is either attached to end of a long alkyl chain or other secondary position have biodegradability and hence they are called soap detergent which alkyl benzosulfate having branched chain alkyl group have pure biodegradability and hence are called hard detergent. To differentiate the detergent of the basic biodegradability alkyl benzosulfonates having long straight chains such as sodium P and benzoyl benzosulfonate and sodium 2-decyl benzosulfonate are called LAC detergent, which those have branched chain are called ABS detergent. As important example of ABS detergent CH3 CH3 CH2 thrice CH copper CH3 benzene SO3 negative and positive. It is prepared by Friedel reaction of of tetramer of formylene with benzene followed by the sublimation and neutralization with alkene. Cationic detergent, these are quaternary ammonium salt containing one or more long chain alkaline group. These are also called inert soaps because their surface activity is due to the positive ion and no to negative ion, as in alkaline hydrogen sulfate detergent being more expensive than the ionic detergent they find limited use. Besides being good cleaning agent, they possess garmanistial properties and therefore they are widely used as it's in hospitals. Non-ionic detergent, these are the esters of high molecular mass alcohol obtained by the reaction between polyethylene glycol and citric acid. Ethylene glycol plus ethylene oxide gives polyethylene glycol. After that, it reacts in the presence of CH3, CH2, 16COH and gives non-ionic detergent. These also be obtained from the long chain alcohols by treating with excess of ethylene oxide in the presence of a base. Like alkyl sulfates, ethyl oxide can be also biodegradable. Hydrogen bonding to the numerous oxygen atom makes the polyether end of molecule water soluble. Alternatively, the ethoxylates can be converted into sulfates and used in the form of sodium salts. Some liquid dishwashing detergents are non-ionic type. Our last topic is composition of a detergent cake. A cake of detergent combines about 20% of active detergent and an equal amount of sodium sulfate to make up the bulk of a powder. A further 30 to 50% of sodium polyphosphate and STPP is added and adaptive. It coordinates with Ca2 positive and Mg2 positive ion present in hard water and thus enhance the clearance efficiency of detergent. Other ingredients include sodium perborate, which act as a bleaching agent, some optical brighteners or fluorinous example organic compound which make yellow clothes appear white, and some chlomics agents. Thank you for listening.